Hi, my name is Thomas. I'm a full-stack Ruby developer. I work for edtech company Pebble. And today I would like to talk about how you can deploy your Ruby on Rails applications and pretty much any other applications to AWS Elastic Beanstalk using Docker. Now, in advance, I would like to apologize as I widely underestimated the scope of the talk. So therefore, I extracted some parts of the talk to blog posts. And so if you find this topic interesting and you would like to see more resources and the demo application source code, everything can be found on the bit.ly link. Now, as for the outline of the talk, first I would like to talk about Docker deployment philosophy, then how AWS is looking at your product from point of view of their products. Then I will introduce what's Elastic Beanstalk and how to use it, and then I will show you some cool features of Elastic Beanstalk. Now, in the talk, we'll be dealing with an example application in which we have our cool Ruby on Rails application. Of course, we need some background workers, so that will be a sidekick. As a primary relational database, we will use Postgres, and we will use Redis as a queuing database for sidekick. For some heavy lifting, we will use Nginx as a proxy. Now, the demo application looks something like this. Unfortunately, I won't be able to show you the application live in the presentation, but if you find this interesting, what you can do is just run the demo application. Again, the source code will be in the bit.ly link collection. So the only functional part is you click the like link of a puppy, and that will basically schedule a sidekick job to increment the like counter in the Postgres database. Oops. So the standard approach would be that if you want to deploy this application, you would configure all the relevant technologies in your laptop. Then you configure these technologies in the server or a VM. And after everything is set up, you start deploying your code. Now, the Docker approach is a little bit different in the sense that we tend to build Docker images for every relevant technology. So what I mean by that is basically Docker image is, I don't want to go into too much detail of what Docker images are, but you can think about a Docker image as you would think about a Vagrant image or VirtualBox image, in the sense that it's an entire stack from operating system layer towards the technology that you are using. The main difference is that Docker images are composed of layers, and these layers are based on root file system changes. So for example, in our Ruby on Rails image, we can build the entire image, and next time when we, let's say, introduce a code change, we only need to rebuild top few layers. Then if we need to introduce a Ruby gem, it will be more layers that we need to rebuild. If we upgrade a Ruby version, it will be even more layers. Everything else remains pre-cached. So how we can actually deploy our images to server? So the main approach would be that you build your Docker images in your laptop, then you push them to so-called Docker registry, and then you tell your server to pull these Docker images. Worth mentioning is that people tend to configure cloud solutions to build their Docker images for them. So pretty much you can configure, let's say, GitHub webhook that each time you deploy to a branch, let's say production branch, some cloud solution will build your Docker image and it will push to the Docker registry. For the talk, it's not really important how we get the Docker image to the registry, but the main part will be that we will tell the server to pull the Docker images. And again, the server will pull only the layers of a Docker image that has been changed. Now, you probably heard this before: Docker container, Docker image. So what's the difference? The main difference is that you can think about Docker container as a runtime instance of a Docker image. Now, there's a little bit more to it, but for the point of the talk, that should be. Yeah, so we managed to pull our Docker images to the server. Now we want to run them as a containers, but we want to run them in the fashion that relevant technologies are connected to each other. So for example, our Ruby on Rails web application is connected to the Nginx, Postgres, and Redis container, and the background worker is connected only to Postgres and Redis. He doesn't care about Nginx. Now, this could be done directly by Docker run command, where we just say, yeah, we want to instantiate a Docker container puppies web based from the Docker image, and then we want to link that container to the database container. Now, in reality, the command in real life application may get way too long. So in practice, we are using tools like Docker Compose, where the configuration is read from a YAML file, and then it's passed to the Docker run. So, for example, you can see here we are saying we want a database container from Postgres image. We want our Redis container to be from a Redis image, proxy container from our custom Nginx image, and puppies web and puppies background worker will be built from our custom Ruby on Rails image. Now, then we're specifying that we want to link database Redis and proxy containers to the puppies web, and for puppies worker, we just want DB and Redis. Now, the Docker link will effectively create a etc/host entry. So all you need to do then in your database YAML to specify the host is DB, and for Sidekick configuration, the host is Redis. So the name of a host is equal to the name of a container, unless you tell it otherwise. So we managed to configure everything on a single server or a single VM. Everything is linked together, and this is pretty much where most of the Docker talks ends. And that's why a lot of developers kind of miss the point that you can do something like this. So you can extract out the individual technologies into your own VMs. So for example, we can run our Postgres container on a separate VM, Redis container on a separate VM, and remain application-specific containers on its own VM. Now, this is especially needed if you are dealing with a load-balanced environment. So we want to introduce more instances as, let's say, overall CPU usage grows, or requests per minute are overwhelming the server. If you decide that it's even a bad idea for you to keep the background worker as a part of the web request responsible VM, then you can totally separate out to a separate VM. It's really dynamic relationship when it comes to infrastructure. Now, we will be dealing with this scenario as it's easier for me to explain, but really you're just limited by your imagination and what the technology can do. Yeah, so in our case, the Docker Compose YAML will look like this. So we are no longer referencing the database, sorry, the DB container and Redis containers. because that's in a separate VMs. And nothing much changed from the proxy container and Puppy's Web and background worker container. We're still using the same image. The bit that really changed is we are no longer linking the containers. We are referencing the IP address of a VM that is running the, let's say, a Redis container, or a VM that is running the Postgres VM. Now, we are setting those IP addresses in environment variables, and then we are passing them to the configuration files. So, for example, our database YAML is referencing the relational database host, and Sidekick, the Redis host. Yeah, in reality, there's more to it, like you need to configure linking of volumes and so on, but the basic is something like this. So what's the AWS approach? Amazon Web Services been on the market for quite some time, and they introduce a product for pretty much any problem that your application may have. So for example, some of the products that we will be needing for the presentation is S3 Simple Storage, which I'm sure pretty much everyone works with. It's for uploading your documents, zip files, whatever. EC2, which is their VM provisioning product. ELB is their load balancer product for EC2 instances. RDS, relational database storage, so we can run our Postgres, MySQL. The really nice thing about RDS is that it's actually really easy to do snapshots of a state of a database. So if you, let's say, run some script and you messed up something in the database, it's really easy to recover. Amazon Elastic Cache, which is pretty much similar to RDS, but it's meant for Redis and Memcache clusters. And Amazon CloudWatch, which is for monitoring and health checks of our EC2 instances and databases. So the philosophy of Amazon Web Services works the best when you are not fighting their philosophy, but you're actually embracing it. And what I mean by that is, if you decide that you are stubborn and you want, for some reason, you want to run your Redis container on an EC2 instance and your Postgres container on an EC2 instance, it's okay, you can. But you're far better off with just using RDS for Postgres and Elastic Cache for Redis in our case. And nothing will change from the perspective of the application VM. We are still running the application-specific containers on an EC2 instance of its own. Now, nothing will change also in the load balance environment. So we are using ELB, EC2 instances running our containers, and everything is connected to Elastic Cache and RDS. So we are finally getting to the point what is Elastic Beanstalk. Now, it's really hard to define the product, but I would say Elastic Beanstalk is a product from AWS that is helping you set up other products from AWS. So what I mean by that is basically, first of all, it's a web-based interface where you just click next, 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 and you end up with EC2 instances running Docker in the load balance environment, some auto-scaling groups pre-configured, some security groups pre-configured, and health checks and monitoring around that. Another thing is they provide a CLI tool, which I would dare to compare with Heroku CLI, in the sense that you just type one command and you do your deployment. Worth mentioning is that it's not only Docker-based technology. They support native Ruby and native other languages. Just I want to keep the talk Docker-based, as pretty much that's my main experience with Elastic Beanstalk. So, as a part of the talk, I wanted to show you how you can set up a fresh new environment. Unfortunately, I don't have time for that, so I extracted those slides to a blog post. Again, that blog post will be part of the bit.ly link collection. So if you want to try it out, it should be easy to set up. So you managed to configure a fresh new Elastic Beanstalk environment. As you can see, we are running Docker. If, let's say, a new version of Docker is introduced, all you need to do is just click change, and you will select the Docker version, and it will automatically reproduce to every EC2 instance. So yeah, our environment is green, which means we are ready for a deployment. So the easiest way to do a deployment is just to click on the upload button and upload a docker run.aws.json file, which looks something like this. So it's similar to Docker Compose YAML, but it's a JSON. But you can see the similarities. We are still referencing the container name, the image name we want to build the container from. We are setting up environment variables, Redis host, relational database host. In our case, we are now referencing not the IP address of a VM, but actual endpoint. For example, Elastic Cache for Redis host, RDS for relational database host. And nothing has changed from database YAML and also for the sidekick configuration. We are still using the environment variables as if we were using Docker Compose. Now, of course, we are web developers. We don't want to do deployments from a web interface. We want to use CLI tools. So in order to do a deployment, all you need to do is to cd into the folder where you have docker run JSON and just type ebdeploy. That's it, you've done your deployment. What this will effectively do, it will compress the folder where you have your docker run JSON. It will upload it to S3, and it will tell Elastic Beanstalk, pull this file. AWS Elastic Beanstalk then pass the configuration file to every EC2 instance, and inside the EC2 instance, what will effectively happen, so-called AWS agent kicks in, and he will read the configuration file, and he will see, okay, I need to pull these Docker images, and I need to run them as a containers and set some environment variables. So this is automatically done when you just type ebdeploy. So we done our deployment. Now we want to see what's the status of the environment. So we just type eb status, it's green, we are ready for another deployment. If it's yellow, it's probably still doing something. If it's red, something went wrong, you might as well check eb events. eb events is something like a log of what's happening on every EC2 instance during the deployment. So for example, you will see, yeah, I'm deploying batch 1 of instances, everything went okay. Batch 2 of instances, yeah, this one instance for some reason was not deployed. So we might as well just SSH to the instance. The easiest way to do that is just type eb SSH and select from the menu which instance you want to SSH, and you can do some debugging. Really, really easy tool. Really quickly, of course, you managed to see we are setting a lot of environment variables in a Docker run JSON, such as database host, database name, database username. The chances are that you want to keep that file in a source control, so under a Git. It may not be a good idea to put there a password or, let's say, some secret API keys. So what you can do is actually set these environment variables from a web interface, and Elastic Beanstalk will pass these environment variables along with the Docker run JSON environment variables to every EC2 instance and to the containers. Now here's an example of some health checks that are automatically pre-configured by the Elastic Beanstalk. As you can see, we have some CPU utilization, some requests per minute, and so on. Here's an example of auto-scaling group. We are saying we want minimum of 1 instance, maximum of 4. We want to introduce new instance based on CPU usage. So we want to introduce new instance when the overall CPU usage is larger than 70%. We want to introduce 1 instance at a time, and we want to kill one of the instances if the CPU usage drops under 35%, for example. There are some other features of Elastic Beanstalk, but the last one that I want to talk about, and it's my favorite, is the swapping of environments. So basically, with Elastic Beanstalk, you can configure as many environments as you want. So you will have your QA running on its own database or Elastic Cache, your staging running on its own Elastic Cache and Postgres. And then what you can do, you can configure your production and your pre-production, both connected to the same database. And really nice thing about Elastic Beanstalk is that you have automatically a URL for every environment. And so, for example, for production, we have our puppies-demo, elasticbeanstalk.com. For pre-production, we have puppies-emo, elasticbeanstalk.com. And basically, our puppies, the main domain, is CNaming to the puppies-demo. So in order to do a deployment, what we can do, we can deploy directly to the prod, but we are risking downtime or maybe something going wrong. So what we can do instead, we can deploy to pre-production, check if everything is working. If so, we will swap the environments, meaning now the production is running on puppies-emo and pre-production is on puppies-demo, effectively on puppies.com. So we will leave it like this for some time. We will see if any airbreak errors are raising. If not, we will deploy to production and we will swap them back. So effectively, you have cheap way how you can do blue-green deployments without any DevOps overhead. In conclusion, when Elastic Beanstalk is good for you. So if you are a startup on a Heroku, and actually I would recommend this. If you are a startup, go with Heroku, figure out what's your product about, what are your database needs, and then when the Heroku bill is overwhelming the benefits, or you just need to move to something else, but you are still in the stage where you cannot afford full-time DevOps person, maybe Elastic Beanstalk is a good choice for you. Also, if you want to go into AWS, learn more about their products, Elastic Beanstalk would be the best place to start. And because a lot of stuff is pre-configured for you, you will just tweak the configuration, figure out what is what, and from there you can move to more advanced products like OpsWorks. Elastic Beanstalk is definitely bad for you if your application is really hardcore about microservices. So for example, if you are running 150 services, you definitely need more advanced tool to do the orchestration. It was designed for monoliths. You can run some side microservices on it, but that's not really the point. It's a really easy environment. If you're also looking for a fully Dockerized environment, meaning you want to run all the containers on a single server, as we seen in the first example, Elastic Beanstalk and pretty much any other AWS VM provisioning product may not be the best choice for you because it's a little bit too expensive for that. Yeah, I'm pretty much already running out of my time, but do we have time for quick questions? Or anyone has any question? Addresses that was like more like an example of like like how you can do it, but it's just like it's like dark side of how you can do the stuff. I personally would do it with the RDS endpoints, and Elastic Cache endpoint, because Elastic Cache will automatically do, let's say, you can introduce more clusters of Redis. Yeah. Or if you decide your Postgres is, let's say, medium, and now you want to introduce like a bigger CPU memory usage of a database, it's easy to swap. Yeah. So I would definitely use like some endpoint rather than static IP address for this. Anyone else? Cool. So yeah, thank you for listening.